This is going to be a video explaining how to do some of the 6.4 Aplia assignments on constructing truth tables and using them to assess the validity of arguments. So these exercises build on the material covered in 6.3, in which we're constructing truth tables for compound statements. What's changing now in 6.4 is that we're going to use the same sort of rules to figure out when an argument is valid and when it's not. And to do that, we're going to do the same thing for setting up truth tables and figuring out when a particular compound statement is true or false given the values for the simple statements. But we're then going to assess whether on a particular line of that truth table, is it possible for all of the premises in the argument to be true and the conclusion false? If it is, that means the argument is invalid. If it isn't possible, that is, there's no line on the truth table where you have all true premises and a false conclusion, then the argument is proven to be valid. All right, so let's take a look at this. For this line, I've got true for Q's. I'm just going to plug that in. Okay, as we go through here. And the next one I've got false for the Q's. Okay, same deal as before with truth tables. What I'm going to now do is work, and here I'm going to note these double bars represent that there's a break between the premises and in this case the conclusion. I'm going to treat these as entirely separate compound statements. So in this case, this is going to be a false, this is going to be a true, and this is now what I'm going to care about. And if you like, what I sometimes do is put a little C underneath the lines that I care about to let me know, hey, like this isn't the main operator for a particular claim. This happens to be the main operator in this case for this side or this particular piece. So even better perhaps to put the X there. But that at least lets me know this is what I care about as I work my way through it. Over here, I need to flip the signs for this Q. That becomes a false. Excuse me. This becomes a true. All right, and now I care about this. This is what I'm using here. I recognize the main operator is this particular line here or column here. It's the conjunction. And now I have true, false. That's a false here. And false, true. That's also a false there. Okay, I'm going to erase that now that I've completed the main operator. And the last thing they want me to do is figure out, is there any line, I've only got two in this case, so not too bad, where I have a true conclusion and, or excuse me, a true premise and a false conclusion, and I do, and that's this line, right? True here, false there. This is the line that shows my argument is invalid, and so I click invalid there, and now I'm going to grade it just to make sure. And lo and behold, we got that correct. So make sure for these that you're putting X's for each of the main operators, and note that each premise, and I think they're all going to give you one conclusion. So for each premise and the conclusion, there's going to be a main operator for each of those distinct compound statements, and then they want you to choose an X in the line that shows the argument's invalid. The lines that are going to show the argument is invalid are those lines where all the premises are true and the conclusion is false. If there is no such line, then the argument is shown to be valid. So what we're doing when we do these truth table assessment is we're actually looking for the case that shows the argument is bad. We're looking for the case where the argument is invalid, where you have all true premises and a false conclusion on a particular line in that truth table. If you have no such line, that proves the argument is valid because you went looking for the case where it would fail and you didn't find it. It means it's not there. Argument's valid. Okay, so let's do another one of these. That one was really simple. This is how they start. These get far more complex as you work your way through it. So I'm going to ramp up now and go ahead to an 8-1. Skip over 4, and then we'll work our way to a 16. Okay. So here they're going to let me know what the premises of the argument are. I mean, it's already labeled here, but just in case, I know one premise is it's not the case that B if and only if not M. Another premise is it's not M if and only if J. And the conclusion then as well, if it or it's false that if B then not M. So here's one premise separated by this slash lets me know it's its own separate part. Another premise, the double slash lets me know this is the conclusion. What I'm going to do is just transfer my values real quick. True, true. These are the all true line, so that's not too bad. Next line I have true and true for B and M and false for J. So true, 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 false, true, true. Now I have true for B, false for M, true for J, true for B, false for M. Okay. Next, it's B is true, the other two are false. So true, false, 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 true, false. And then I have B being false, the other two being true. And what we got next? We got false B, true M, and false J. False B, false M, true J. Ooh, did I get that right? Yes, I did. All right. And then false for all of them. This last main column line was kind of throwing me. Okay, so now for each of these, I need to pick the main operator, which they're calling main column here. For this first claim, the main operator is the one thing outside of parentheses, which is my negation. Second one, my main operator is actually the triple bar, because the negation only applies to the M. There's no other parentheses to differentiate things. And this last one is going to be the negation again. It's the one thing outside of my premises. Okay, so now what I'm going to do is work my way from inside to outside to get to the main operator. I want to flip all these values. That's a false, false, true, true, false, false, true, true. And now I'm going to put this. I'm going to put a C here just to remind me this is the line I care about. Over here, flip this one. And I'm flipping those because of this negation symbol. And same thing over here. Notice that every time M shows up in this particular argument, it's always negated. All right, I'm going to put this C here to remind me I care about this. Okay, and now I'm going to start on the left and work my way over. So on the left here now I have a true false. For a biconditional, that means it's false. The signs need to be the same. So those two are false, these two are true, 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 false, false. Okay, and now I don't care about this anymore. I only care about this. All right, and now I'm going to do the main operator. So the main operator is going to take this value here that I care about and flip it for each of these. So I'm going to do true, true, looking at these middle lines, false, 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 and then true, true. Okay, that was just negating each of these lines, which is what I cared about at this point. All right, and now I'm going to get rid of this C. Moving over. I have this line I care about, and I'm comparing it to this to get the value for the triple bar, which is a false here, true there, because these two are the same. Now they're different, so it's a false, false, true, true, false. Okay, I'm going to erase this. I no longer care about it. And over here, do inside the parentheses first. So I have a conditional. I know for a conditional, every line in which the antecedent is true, it's just automatically true. Because the, or excuse me, let me take that back. Forget what I just said. Every line where the consequent is true, it's automatically true. But here I have a true antecedent, false conditional. That's false, false. This one's true because it's got a true consequent. This one is the one, if I have a false antecedent, that means the conditional is automatically true, because the only time a conditional is false is where the antecedent is true and the consequent is false. So as soon as I know the antecedent is false, automatically conditional must be true. So I'm getting rid of this now because I care about the middle line for the conditional. And now I'm going to flip all these values. So true, true, false, 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 and false. Okay. So that's the truth table filled out for this argument. What I now need to do is look to see, are there any lines where I've got an all true premise situation and a false conclusion situation. So here I have true premise, false premise. I don't need to worry about that. That cannot invalidate the argument. The only lines that can invalidate the argument are those where all the premises are true and the conclusion is false. So I should adopt a kind of strategy here in looking. I can either look at the conclusions first and realize, well, any line where the conclusion is false can invalidate the argument, so that stays. But any line where the conclusion is true, that couldn't possibly invalidate the argument, so I can ignore those. Like, I'm going to ignore these first two lines for that reason if I'm just looking here. Okay, but all of the other lines can potentially invalidate if all I'm looking at is the conclusion. So now I go over, here's a false premise, that's out, false premise, that's out, false premise, that's out, false premise, that's out. Only two that could do it at this point are these two. So this is a true, and a false. This is a true, and a false. So actually, both of the last two lines invalidate the argument. They are both cases where the argument has all true premises and a false conclusion. So I want to make sure I put X's in both. I'm going to select invalid. I'm going to go ahead and grade this thing. And there you have it. So that is an 8-line proof, or excuse me, not a proof, a truth table for the argument. I'm not going to do these just for the sake of time. This takes quite a bit of time just to punch in the values and go through. What I'm going to look at really quickly then is take a look at inconsistent premises and then the abstract application. So here what they want me to do is fill out the truth table once again, and I'm going to be looking for cases where, if you look up here, tautologous conclusion, that's an argument must be valid because it's impossible for a tautology to be false. It's impossible for an argument with a tautologous conclusion to have all true premises and a false conclusion because a conclusion is just always true. This is an argument I can already tell is tautologous because this conclusion will never be false. It's always going to be true that L are not L because regardless of what value you have for L, at least one of the sides is going to be true. So that's what you're looking for. A case where conclusion is always true, that's a tautologous argument. A case where a argument has inconsistent premises, that means it has premises that both can't be true at the same time. So like one premise automatically makes the other premise false, sort of by definition. That's going to be an argument that has inconsistent premises. That is, when one premise is true, the other is false, and vice versa. They're never true at the same time. And that argument will also be always valid because you would never have a case where both arguments were always, or excuse me, both premises in the argument or all the premises in the argument were always true, and that's what you need to show that an argument is invalid. So for this, what you're looking for is after filling out the truth table, is the conclusion always true? If it is, it's a tautologous argument, or, and therefore valid, excuse me, or you're looking for a case where when one premise is true, the other one is false, and or vice versa, so they always have different truth values, in which case you would have an argument that has inconsistent premises, and therefore is also valid, always and everywhere. Okay. And then lastly, let's look at abstract application. So this one, just looking at it, is just going to ask you questions about how these arguments should work based on stuff that you know and based on truth tables. You don't have to fill anything out, which is nice, but you do have to have a pretty good working knowledge of how truth tables and argument validity assessments work together. So take this first question, true or false? An argument in which the premises of the conclusion are all contingent statements must be an invalid argument. Right? So this is building off of the tautologous and inconsistent set. What it means if an argument has premises and conclusions that are all contingent, that means that they're not true or false necessarily. They're true or false depending on what the values of the individual statements within those compound statements are. So it's not like, well, given this compound statement, it's always going to be false, or it's always going to be true. So examples, like the compound statement P and not P is always false. The compound statement P or not P is always true. But these are contingent, that is, their value depends on what the values of the parts happen to be. Because of that, I wouldn't know whether an argument in which the premises and conclusions are all contingent, that doesn't tell me whether they're always false, or excuse me, is always invalid, or always valid. Because it could be the case that you'd have all true premises and a false conclusion. It could be the case that you didn't. So I would want to check false for this because I wouldn't know whether it's always invalid based on that claim. Now, moving to the next one, an argument with a tautology for the conclusion must be valid. That's true. And I know that because an argument with a tautologous conclusion means conclusion is always true. So there would never be a case for that argument where I would have a line in the truth table where I'd have all true premises and a false conclusion, because the conclusion is always true, therefore argument is always valid. It would never pass the invalidity test. That is the case where I'd have all true premises and a false conclusion. All right? And that's what you're going to do for that particular exercise set. And I think that just about wraps it up, because the last set in this is just the true or false, which is the pretty standard stuff that you're used to. If you got any additional questions, shoot me a message on Canvas. Happy to answer it.